Hi, this video is going to prepare you for the test that we have tomorrow. This is Unit 5.3. The formulas at the top of your paper are the formulas that you're going to get on your test. The first formula is when you're given a binomial and they ask you for one specific term. This formula right here is when you have a population problem about exponential growth or decay. These three formulas are all your money problems, and this problem at the formula at the bottom is your cooling problem, your Newton's law of cooling. All right, so the first four problems are about limits. And what you need to remember about limits is that we had a saying. It was Bo Botten eats DC. Okay? And we use this Bo Botten eats DC to remember what a limit approaches as the number gets closer and closer to infinity. When you're using Bo Botten eats DC, you're using it for your rational functions like number 1, number 2, and number 3. And what we're doing is we're looking at our biggest exponent on the top and our biggest exponent at the bottom. So number 1, our biggest exponent up here is 1, and down here it's also 1. So is it bigger on bottom, bigger on top, or are the exponents the same? Well, these exponents are both 1. When you have your exponents the same, exponents are the same, it says DC. That means divide the coefficients. So 2 divided by 6 equals 1/3. Number 2 is another rational, so we're going to use Bo Botten eats DC. The biggest exponent on top is 2. The biggest exponent on bottom is 1. So is it bigger on top or bigger on bottom? It's obviously bigger on top, so we're going to say that the answer is infinity, or you might also see does not exist. Number 3, it's another rational function. The exponent on top that's the biggest is 1. The biggest one on the bottom is 2. This time it's bigger on bottom, so the answer is 0. Number 4 is not a rational. This one is just a decimal number. When you have a decimal less than 1, like this, 0.99, raised to the exponent of x, as x approaches infinity, the answer will be 0. So if it's less than 1 raised to the infinite power, it's 0. If I had something that was bigger than 1, like 1.01 raised to the x, the limit of this would equal infinity, or sometimes they write does not exist. On your test tomorrow, you're going to see infinity, not does not exist. You're going to see these two. Okay, on 5 and 6 for both of these problems, they're asking you to go find an amount, which means I'm going to look for a formula that has to do with money. The first one says that we have $1,300 invested at 15% compounded semi-annually for 14 years. You have to remember tomorrow on your test that semi-annually means n equals 2. So I'm looking at my formulas up here, and I want a money formula with an n in it. Well, the only money formula with an n in it is this one right here. So I'm going to plug in, and the formula says you're going to put P first, which is the amount of money we started with, $1,300. Then it says 1 plus R. My R is 15%, which is 0.15, divided by n we said was 2, raised to the n times t. My t is 14. So you're going to type this in your calculator. When we typed it in, we did it in pieces the other day. So I did this first, 0.15 divided by 2. Then I added 1. Then I raised it to the 2 times 14, which is 28. Oops, I don't need that. And then once I get that answer, I have to multiply it by the 1,300. So we get $9,848.73. So $9,848.73. Number 6 is the exact same type of problem, but this time they say it's compounded annually, which means n equals 1. Exact same formula, but where I had 2, I'm going to replace it with a 1. So 0.11 over 1 to the 1 times 9. So you can type it in your calculator. So we have 0.11 divided by 1 plus 1 raised to the 9 times 1,500. And we get $3,837.06. Remember to round to the nearest cent. So $3,837.06. Okay. When you get to problems like 7 through 9 tomorrow, this has a process. When you see the words effective rate of interest, you have to remember the process. The process for problems with effective rate of interest are to let P equal 100. You're going to let T equal 1. You're going to solve for A. Then after you solve for A, you're going to subtract 100 from it. And then after you subtract 100, you'll get your answer. Okay, so they want to find the effective rate of interest compounded continuously. When you see the word continuously, that tells me to use my PERT equation. So this is the equation I'm plugging into. And because it's effective rate of interest, I said we're going to solve for A. We're going to let P equal 100. The rate they want me to use is 0.08. And I said we're going to let T equal 1. So you go straight to your calculator, and on this problem, you can type it all in. So 100, your E button is your second LN to the 0.08 times 1 is 0.08. So you get this giant number, $108.33. Okay, that's the total amount that you earn, your total amount of money, but now I have to go subtract 100 from it. So we get 8.33%. Number 8 is going to work the same way, except I'm going to use a different formula. This time they say monthly. So the one above it said continuously. That's your PERT equation, this one right here. This problem I'm doing right now, number 8, says monthly. Monthly means I have an N, so I'm going to use this formula. And because it says monthly, N equals 12. So A equals 100, 1 plus R, 0.105. Monthly means N equals 12 to the 12 times T, which is 1. So you're going to type all that in your calculator again. So 0.105 divided by 12 plus 1 raised to the 12 times 100. And then you're going to subtract 100 from it. So you're going to have 11.02%. So it was 101.02 minus 100. That's 11.02%. Okay. And the last one, we're going to compound quarterly. So that means if you're going to compound quarterly, that your N equals 4. So I need the exact same equation that we had here, but where I have the 12s, I'm going to have a 4. So A equals 100. 1 plus 0.0725 divided by 4 to the 4 times 1. And we're going to type it in. So we have 0.075 divided by 4 plus 1 raised to the 4th times 100. And we get $107.71. 107.71. We're going to subtract 100. So my answer is 7.71%. So it's just a matter of plugging in and remembering to let P equal 100, let T equal 1, solve for A, and subtract 100. You have to know this process when you see the words effective rate of interest. On 10 and 11, we are finding the P, the present value. So on number 10, it tells me that we're going to compound annually. So N equals 1. So I need to use one of these formulas that has an N, which happens to be this one, and I'm going to look for P this time, because that's what they asked me to solve for, the present value. So I know A is 4,500. I'm looking for P of 1 plus my rate is 0.10 over 1 raised to the 1 times 5. So this time we're solving for this. So this says P times all this stuff. So if I can find all this stuff, I'm going to divide 4,500 by whatever I get here. All right, so this is how it looks in the calculator. So we're going to type in 0.10 divided by 1 plus 1 raised to the 5. Let me get this decimal here. So I'm going to take the 4,500 and divide it by this answer that I got in the calculator. So I type in 4,500 divided by second answer, and we find out that the present value is equal to $2,700 $94.15. Number 11 is going to work the same way, except that it says semi-annually, which means n equals 2. So we're going to have 6,000 equals p to the 1 plus 0.07 over 2 to the 2 times 8. So again, we're going to type this in our calculator, get an answer, and then take 6,000 and divide it by what the calculator said. Okay, so 0.07 divided by 2 plus 1 raised to the 16. So this is the decimal I got. So now I go type in 6,000 divided by second answer. And we get $3,460.24. Okay, so that's the first page of your review. Check out the next video for the back.